Hi guys, today we're going to go over simplifying radicals, and a radical is just another way of saying square root. So we normally start with perfect squares. Now perfect square is a number that when you square root it, you get a whole number. And let's go ahead and try to write down all of your perfect squares up to 12. So what number, when you square root it, do you get 12? And that is 144. And kind of going off what we talked about in our last lesson, when you have the square root and the number is squared, they count as like opposites, and that's how you get the answer of 12. So what number, when you square root it, do you get? 11? And that's 121. And then let's keep going. 181, 64, 49, 36, 25, 16, 9, 4, and 1. So whenever you have these, they're pretty easy. It's just a whole number. That's the answer. But that doesn't always happen. So let's try a number that is not a perfect square, like 20. Now, when you were in middle school, maybe you were taught how to do a prime factorization tree. And the way I do it is I use a box, which is essentially the same thing as the prime factorization tree. So I write the number 20 because that's what's inside the square root, and I draw like a little half box around it, and I say to myself, what goes into 20? What prime number goes into 20? And I like to start with 2. It's pretty easy, just divide by 2, and I say, sure, 2 goes into it. So 2 goes out here on the outside. That's a prime number. So then I have to ask myself, okay, how many times does 2 go into 20? 10. So I write 10 below it. So let's draw another little box around it and say, okay, what goes into 10? What prime number? Does 2 go into it? Of course. So again, I put a 2 on the outside, and I say 2 goes into 10 5 times. Now, 5 is a prime number. Nothing besides 5 and 1 goes into it, so I am finished. These 3 numbers, and let's check it. When you multiply them, that little dot means multiply, should go back and give you the original number of 20. So 5 times 2, and then 10 times 2 is 20. So we're on a good track so far. Now we're not finished. Now, a silly way of thinking about it is, okay, couples go on dates, right? So they have to match up exactly. So the 2 and the 2, they get to break out of the square root, and they go on the outside. So notice the 2's on the outside because you had one group or one couple of 2's. Now this little 5 is left over. There's nothing to match it with. So the 5 stays on the inside. And this is your reduced final answer, 2 root 5. Now, again, if you like prime factorization trees, there's nothing wrong with doing that. You get the exact same answer. It's just a matter of which method you like to do. So notice you're left with the 2, 2, and 5. Now, again, building off of what we talked about last class, if you like simplifying the square root in the square and seeing this 2 breaks out and this 5 stays, that's another method that will give you the same results. So let's try a bigger number. Let's try to simplify 75. So again, I take the 75, I put a little box around it, and I start with 2. Does 2 go into it evenly? No. Does 3 go into it? Of course. So 3 goes into 75 how many times? And that's 25. So let's keep going. What goes into 25? 2, 3, 5. So I always start with the lowest numbers and kind of work my way up. And 5 goes into 25 5 times. So we have our prime factors. So 3 times 5 is 15, and 15 times 5 is 75. You can multiply these in any order. 5 times 5 is 25. 25 times 3 is 75. So when you're checking, remember the order really doesn't matter when you're multiplying. So let's match them up. Okay, so remember the numbers have to be the same. So what should match? Well, there's 2 5s, so that 5 gets to come on the outside. Notice it's here. Now, what number's left over? The 3. So the 3 goes on the inside. And this is your final answer. Now, if you wanted to do it this way, you could see that this 3, there's not a square, so it stays on the inside. The square root and the square cancels. So writing it like this, the square root of 3 times 5, is really not the proper way of writing it. We always put the number without the square root first, and then the square root. So it's 5 root 3. Okay, so let's try a bigger number. 80. So let's put 80 on the outside. Does 2 go into it? Does 3 go into it? 2. 40 times. So let's draw a box around the 40 and say 2 goes into 40 20 times. And 2 goes into 20 10 times. Are we finished? No, because 10, you can still reduce it down. 10 is 2 times 5. So guys, we have lots of prime numbers that multiply together to give you your original number back. And again, I would recommend that you check it. You can grab a calculator or try to do it in your head. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. And 40 times 2 is 80. So I'm on the right track. Now let's group these together. I have one set here. Let's look like a couple. I have another set here. And then notice I have the leftover little 5. So 2 sets get to come out of this radical. So notice over here, here's the one set, here's the second set, and then the little 5 just goes back on the inside. Here, I'll have to do it with the clicker. All right, now we're not finished because this 2 and the 2 need to be multiplied together. There's a multiplication in between them. So let's multiply those back together, and you get the answer of 4 square root of 5. And, again, it doesn't matter the method, you get the same answer. If you like this method, the square root and the squares cancel. The 2's get to come outside the square root. And then you group these back together to get 4 root 5. All right, let's do even a bigger number, 450. Now again, let's take the 450, put a box around it. And you can start with, any prime number. I chose to go by 2. If you would like to go by 5, that's your choice, but I always, for consistency's sake, start with the smallest number. So 2 goes into 450, 225. And then again, I say, does 2 go into it? Does 3 go into it? No, what goes into it? Okay, 3. I was almost going to say 5. 3 goes into it 75 times. And then 75 is 3 and 25. And then let's break that down again. 5 and 5. Okay, so again, if you want to grab your calculator, I have mine here. 5 times 5 is 25, times 3 is 75, times 3 is 225, times 2 is 450. Okay, so I'm good to go. Now let's group them together. I have a set of 3's. I have a set of 5's. So 1 3 and 1 5 gets to come outside the square root. 1 3 and 1 5. And this little 2's left over. So that 2 goes on the inside. Now, keep in mind, you're not finished. 3 times 5 is 15. And bring down the root 2. So your answer is 15 root 2. Now, guys, I know it's some work, but this is the process. And you will get faster as we go. I'm going to give you 3 problems here. And I want you to pause the video and attempt them. So when you're finished, unpause me and we will go over them. All right, guys, hopefully you've tried the problems at this point. So let's go over these. For the square root of 32, I get 4 root 2. So let's go over how you get that. That's 2 and 16, 2 and 8, 2 and 4, 2 and 2. So I have one group that comes out, a second group that comes out, and then the 2 remains inside. So I have the 2 times 2 root 2, and those come together to give you 4 root 2. Okay, so how'd you do? If you have questions, please message me, and I'm happy to help you. Let's try the next one, 125. Now, what goes into 125? 2, 3, 5, Okay, so I have 5 and 25. And then that's 5 and 5. So again, I'm going to check it. 5 times 5 times 5 is 125. So I'm good to go. I have one group. And so this set of 5s comes on the outside. This little 5 stays in. So my final answer is 5 root 5. Let's try 50. Okay, so 2 goes into it 25 times. And then 5 goes into it 5 times. Let's check it. 5 times 5 is 25, times 2 is 50. Okay, so I have one set, and that 5 gets to come on the outside, and the leftover little 2 goes on the inside. So my answer is 5 root 2. All right, so how'd you do? Again, if you need some help, please contact me, and I'm happy to help you through whatever troubles you're having. Now let's try to mix it up just a little bit. We're going to start with a number where there's like a 2 in front of the square root. So when you simplify this, it's just one additional step. We're still going to start with the root 45. Okay, so let's do our little factor tree of 45. And so what goes into 45? 3 does, 15 times. And what goes into 15? 3 does, 5 times. And again, you can multiply these in any order. 3 times 3 is 9. 9 times 5 is 45. So I know I'm good. Now, do you have any matches? Do you have any dates here? So we have the 3 and the 3. So the 3 comes on the outside and the 5 stays on the inside. But this is the wrong answer. And it is because this little 2 needs to be addressed. This 2 needs to come down and be multiplied by the 3. So my final answer is going to be 6 square root of 5. So don't forget to address the little number in the front and bring it down when you're at the end of the question. All right, so here's some work that I had already typed out. Let's just get through it. And as you can see, I also had 6 root 5 down here. All right, let's do another one. All right, so go ahead, pause me, and I would like for you to try these 2 questions and then come back and we will go over them. All right, guys, so hopefully you have these completed. Let's go over them real quick. 2 goes into 8 4 times, and then 2 goes into 4 2 times, because 2 times 2 is 4, times 2 is 8. I have one grouping, so 1 2 gets to break out. This little 2 has to stay in, but I have to deal with this 7. So that 7 goes on the outside, so I have 14 root 2. Now, on the next one, I noticed something special about this. This is a perfect square. The square root of 36 is 6. So really, all you have to do is multiply these 2 together to get 24. And you're finished. And one last slide. We're going to multiply square roots together. Now, adding is a completely different story. We're multiplying right now. And when you're multiplying, I'm going to put a little dot in here. If the number's on the inside of the square root, you can just multiply it with a number inside a different square root. And actually, you can kind of combine them. So it's easier to think about if you just put them both underneath the radical, 2 times 3, which would be the square root of 6. Pretty easy. Now, I want to add a problem in here and just call it question 11 and a half. What if I had 2 root 5 times 3 root 2? Now, if I have this question, again, numbers on the inside of the square root stay together, and then numbers on the outside stay together. So I would do 2 times 3, which is 6, and then I would do the square root of 5 times 2, which is 10. And so just remember, numbers on the outside you can multiply with each other, and numbers on the inside you can multiply with each other. So it's pretty easy. On the next one, you're probably getting ahead of me and saying, oh, that's easy. That's the square root of 120. I just multiply them together. And you're right, it is the square root of 120. But we're not finished because it's not simplified. So do your factor tree. And I went ahead and did that for you. And I have the answer of 2 root 30. So make sure your final answers are always simplified. All right, that is it. So please watch again if you need some help or contact me, and I'm happy to help you. And good luck. Thanks.